wabarakatuh. My name is SYAFIK. Today I would like to present the final year project, which is titled Security and Performance Analysis on Blocking Online Advertisement using Python. So first of all, the background study for this project is the implementation of the Pi-hole as a ad blocker to block the online advertisement that has been installed in the Raspberry Pi. And um, uh, for this project, the security and performance analysis will be evaluated to determine whether it can solve the problem, and also the objective of the project can be achieved. So the problem statement is online advertisement can affect the value of the network. Since there is many type of online advertisement, one of them is the online advertisement that attach with a video. Since the video had a large bandwidth, it can consume more bandwidth to the user. Second is Raspberry Pi. Raspberry Pi has some weakness and vulnerabilities to a malware attack. Uh, this can be proved when uh, the configuration of the Raspberry Pi is default. It means that there is no firewall, no other security measurement to the Raspberry Pi during the configuration. Third, the network attack, such as the DOS attack, brute force, and others, can affect the performance of the network. So the objective for this project is to design an advertisement blocker using Pi-hole, to evaluate the network performance of the Pi-hole, to evaluate the network security of the Pi-hole by performing DOS attack and brute force attack. Fourth, to improve the security and provide countermeasure for each attack performed to the Pi-hole. For the literature review, the information that I have gathered from the article is related on advertisement, Internet of Things, Raspberry Pi, VPS, which is the Virtual Private Server, Kali Linux, VPN, Virtual Private Network, IDS is intrusion detection system, and penetration testing and network performance tool to do the network performance analysis on the Pi-hole server. So the methodology for the requirement analysis phase, the objective of this phase is to collect the project information. So the outcome that has been can I have from this phase is the software requirement and hardware requirement that used to complete this project. Second, the design phase. The design phase is to design the project uh, so that we have the clear sight of how we want to do that. And the outcome is the system architecture. For the system architecture, this is the system architecture um, before the improvement of the security, which is this is the architecture that we will test using the network security tools, penetration tool. The Pi-hole will be installed into the Raspberry Pi using the Raspbian, and then the Raspberry Pi will be connected to the router by using the Ethernet cable, and then the client will connected to the router, and the router will connect to the internet. The second network architecture in system architecture is this is the improvement of the Pi-hole server, which is before this Pi-hole server is installed on the Raspberry Pi, but now I changed it to the VPS, since the Open VPN can be run alongside the Pi-hole server. OpenVPN server cannot be installed in Raspberry Pi. If we want to do the um, um, if we want to access the Pi server from outside of the network, which means if it can be used on the go if we install in UPS. The reason is because the IP of Raspberry Pi is behind the NAT, and my router didn't have the IP forwarding feature that can forward the IP to the internet. In the configuration phase, the objective is to combine and integrate all the hardware and software required. The form is brute force attack. Brute force attack can guess the password of the Raspberry Pi. Now I copy the nmap to ping the live host in the network. As the execute, the IP address of the Raspberry Pi is found. The IP address is 192.168.0.101. Now I will check the open port for the Raspberry Pi. From here, I will have found the open port for the Raspberry Pi, which is SSH, domain, DNS, HTTP, and BNC. So in this attack, I use the Hydra to do the brute force. As we can see, the username is for the default is 5, and this is the location of the list that we will use to get the password and the login. So we use the SSH as it is one of the open port. This is the victim or the Raspberry Pi IP address. This is the username that we will use, and this is the password that we will guess. So we will take a minute before we will found the name. As we can see, after the HTC Atom, the password and the login has been found, and this information will be used to connect to the SSH connection to the Raspberry Pi. So now we have the access to the Raspberry Pi, and this is the config for the Raspberry Pi. The next attack is a DOS attack. As you can see, we will try to ping before the DOS attack has been launched. So the initial latency for the from Kali machine to the server is 1.37 and so on. And as you can see, latency. So after we try the command sudo http that will send a packet to the Raspberry Pi flat. We try to ping again. Now the latency had increased. - 106, and the DOS attack has been done. On how the improvement of the script for the firewall server that has been installed in the VPS and the implementation of IDS in the Raspberry Pi. First of all, we need to connect to the VPN to have the okay. So we can manage the VPS by using the VPN connection, and also we can although we use the different internet from the Raspberry Pi, we still can access to the remotely to the Raspberry Pi using the IP address for the VPN of the Pi. So you can see here um, the tunnel the IP address for the interface tune 0 is 10.8.0.7, and from here we can access the connection to the Raspberry Pi is not over the internet. This is the internet. So we try to see the status for the VPN, the firewall is running and the VPS is active, and so this is the status of the asset that successfully run on the Raspberry Pi. So we can access to the firewall interface by using uh, the IP address of the VPS for the VPN connection. This is the query block and the person block script. So we can log in. So this is the query, and also the query blocker will be displayed in the firewall interface. This is the domain, top blocker domain and the top connected domain. This is the client of the Raspberry Pi of the firewall. The connection to this firewall will only allow the connection from the device that connected to the VPN, which is this firewall internet interface will use the Tune 0 interface, which is the interface for the Open VPN that we have been installed before. So we can see the query log that have been provided, and also there is the period that has been blocked or allowed will be shown in here. So we will see the accessible. So this is the web user interface for the accessible. Uh, the server we installed in the Raspberry Pi, which is on 10.8.0.7 IP address, and there is 3 engine that has been installed. This is the latest event that will be displayed here, and if the level 10 rule is triggered, the firewall server, the accessible will send a alert to the user email. Um, for the VPS and Raspberry Pi, I had installed the firewall, which is used for the Linux, which is the FYP. You can see the firewall will only allow the connection to the port 80, 53, 25, 22, and 53 only from the 10.8.0.0 network, which is the network that has been used for OpenVPN. And from here, the brute force attack can be done since it only allow the connection from the device that connect to the OpenVPN. Okay, from here we can see that the offset has been sent the email to the user to tell that there is a whether any rule has been triggered, and then it will show the log from the accessible.